Hello, this is Daniel Ritchie, the developer of Howler, and today I'm going to be talking about Lightwave again. We are going to be releasing Howler 9.5 in a few days, so just stay tuned for that. But today I'm going to be talking about Lightwave and using nodes to create a subsurface scattering shader. So let's just jump right into it. There are a number of things we have to do to solve the problem, so we're going to just take it one step at a time. The first thing I observed when deciding how to work this out was that, say you take a shader and make it translucent, which I'll do with this purple donut up here. Makes a Homer sound, donut. And let's say we make that transparent or translucent. Well, you see the light shines through to the other side of the surface now, but there are a couple problems. One, it's the same color as the side with the light actually shining on it, and two, well, it just passes right through. It doesn't spread out, it doesn't scatter or anything like that. So the first problem I want to solve is to make this light spread out some, as if the light is shining into the object and then the beams are splitting and spreading in a way that is more realistic instead of just passing straight through. So let me go ahead and move the purple donut off the screen, and we're going to look at this white donut down here. It's a sweet, delicious powder donut, and that's all I'm going to say about it. Alright, so the first part of the node we wanted to create was a way to spread that light out, and we're going to do this by using bent normals. And let me go into this node for this surface and show you. This is a compound node that was included, I believe, in my last build of the archive that was presented on the new tech list, the forum on the new tech website, and it is called bend normal to object. And let me just briefly show you what it requires to set up. We need a world spot, which is the spot that we're actually shading on the surface. That's one of the inputs. And we need a surface normal. That's not the geometric normal, the smooth normal, just the regular normal. We plug those in, and we also need a light position. If you look here, the item info that we've set up is for that light, and we take the world position, not the regular position, but the world position, and we plug that into reference world position. We also need a value between between 0 and 1, and we just used for this demonstration, we used just a scalar, which is under constants, and there's a scalar node there. And if we set this to 0, our shading will be exactly as you expect it to be under Lightwave, and I'll just move the light around to show that. Pretty much exactly as you would expect it to look. Now if we set this a little bit higher, you'll see, say point 0.3, and now you see that our light really starts to spread out and use up more of the or cover more of the surface area, almost in an unnatural way, because our light is sort of wrapping around the object. It's not just shining in a straight line anymore. And let me go a little higher, 0.5, and you'll see this object, or 0.6, and the object has suddenly become almost completely illuminated. Say 0.4 or 0.5, it'll be a little bit less, and so on. And if we went to all the way to 1, it would just be completely illuminated. The reason for that is because we are taking these surface normals. As you remember, the normal is a vector, or just a line that points from the face of a polygon outward, and it just gives the renderer a clue, or pretty much the information it needs to know which way that face or that polygon is facing, so that it can render it with the proper lighting. So what we've done is we've taken these surface normals and we bent them towards our light source, which is over here. This is just a point light, and what this does is now this surface thinks that it's being shined on almost completely by this light, instead of part of it being occluded by its own self, for example, or part of it being facing 90 degrees away. Now it thinks like the entire surface, or almost the entire surface, is having this light shined on it. And we can have various levels. That, like I said, point 3 would be mostly shaded, but still some of the back is not really being shined on. So that is the first step we had to go through to create this subsurface scattering node that we've talked about. And let me go through one more step here. We're going to subtract. We're going to invert this normal so that the surface thinks is now reversed, as if it was not double-sided, but the polygons were flipped and now on the inside of the donut, or the toroid. So we're going to go to a vector multiply. Vector just means there's 3 values there instead of just a single value. That's like X, Y, and Z. We're going to get the multiply mode right there, and we're going to plug our normal into it. And for the B part of this, we're just going to put -1 for each of these inputs. Now we'll have the effect of flipping our normal backwards, so we don't have to plug in a second input because we just set a constant for that. And I'll put that into our normal, which will now, as you should see here, have our light shining on the opposite side of this donut. It's as if we had flipped the normals of our surface. So there you go, there's that. Now I'm going to go into a scene that I already have set up in another instance, and we've gotten a little bit more complex with our node here. We've added a bump map to our surface, so you see these scales. It just gives us a little something more to look at. This is just a real in-between dinosaur model that I was working on at one point. Not finished by any stretch of the imagination, but basically just fleshed out or roughed out. And as you can see, the building block for this is that bent normal routine we have here. That's what lets us spread out this light in a way that is not linear. And we're also going to use some random normals as well to get these to make these ray tracing rays spread out, and not if we had not spread these out with a random normal, you would see the back faces of these polygons basically, and it wouldn't look very good at all. So we also have in here somewhere a random normal. We've averaged that normal again with the original normal to keep it from being completely random, so that it has some of the surface detail. And we've done a few other things. It might take a while to go through all of this, but I'm going to show you some of the basics anyways. There's a Lambert shader in there. That's where we get the green part from. That's just a pre-built Lambert shader. We might want to swing our own at some point, given more time, using a dot product of the vector between the light and the surface normal. But for now, we're just going to go ahead and use a Lambert shader to get that green part. We've basically, forgetting about this gradient here for a minute, we've basically plugged in our, let's see, our bent normal into this Lambert shader, and the color went out, and it is combined with our let's see our ray traced, which is here, this thickness thing here. Whoops, need to open that up. This thickness thing here goes into it goes into this goes into a actual make material. We output the material to the surface. Alright, so that's all fairly complex looking, but as you said, we started with basically this bent normal function we wrote and some random normals. Alright, the main functional part of this, without getting lost in too much detail, is this, as I was saying, this thickness, which is, I believe, a tool under Raytrace perhaps, or maybe under gradients. Let's see. Tools, yes, thickness. Under gradients, tools, and thickness, you'll find this, and it takes two parameters. One is the normal, and one is the index of refraction. I believe I set a refractive index to 2 as a constant, and the normal going into that is our random normal that is averaged with a regular surface normal. It's just half one and half the other. That gives us a normal that is slightly random and slightly based on the shape of our original surface, about half, well, exactly halfway between the two. That normal goes into this thickness node, and it is the length that we output, which is then divided by, let's see, divided by our Lambert shader, and then added to our other Lambert shader. Okay, one Lambert shader is red and the other one is green, if I've got that right. Yes, here the red is coming from this gradient, which is red, as you see there, is based on incidence angle. Alright, so one Lambert shader is green. As you can see, this green that is coming from our light source. If our light was right in front of the object, we would see this green, and if our light is behind the object, we will see this red. Alright, that is controlled by this thickness node, or the red is, let's see, and basically what this returns is the length or the distance that ray travels through the object. And like I said, if we had not used a random normal for that, we just use a regular normal for that, you would see, although I do have an index of refraction there, you would see these sharp creases and all this weird stuff, because you're basically seeing the insides of the polygons and the insides of the object. That's why we use that random normal. Alright, so I'm not sure if I can get that back, but let's take a crack at it. Let's see, I think that goes there, and that gives us our randomness. Alright, yes, that is correct. So in a nutshell, the thickness, going into the dividing, let's see, dividing the shader, the red shader, by the thickness, and adding it to the green shader. And it's hard to explain that in a few words, but that is how we created this node. Hope some of this has been informative, just to show that it can be done, at least, if it wasn't very clear. Shows you that by using a random normal, we're able to ray trace the insides of, or scatter the light inside of an object using the thickness node. Alright, so that's about all that I can do with it. I'm not sure I can really explain it with any kind of justice, so hope that's given you a few ideas, giving you a little more exposure to the node editor, which is incredibly powerful. You can basically write your own features now in Lightwave without having to wait for some programmer to come along and do it for you. As I said there, in about 10 minutes, I think we whipped up not only a solution that would let us do translucency in a more realistic way, but also a complete subsurface shader using subsurface scattering, that is. And well, maybe not quite production ready, but it is a good start on it anyway. So that's about all I can say about it. Talk to you later. Hope you enjoyed the tutorial, and ta-ta for now.